Lesson 3.5, Arithmetic and Geometric Sequences, Day 2. Our essential question is, how do you write an equation for an arithmetic or geometric sequence? How do you write an equation? For an arithmetic sequence, the general form is f of x equals mx plus b, which makes it linear. Just like we learned in section 3.1, it will be a straight line if you graph it. Notice that it says where x equals 0, 1, 2, 3, and so on. The geometric sequence has the general form f of x equals a times b to the power of x, which makes it nonlinear because it has that exponent of x that actually creates a nonlinear graph that's exponential. So where a linear graph is going to be a line, whether its slope is positive or negative, 0 or undefined, a nonlinear graph like this will create an exponential curve where something increases really rapidly or decreases really rapidly. Notice again it says where x equals 0, 1, 2, 3, and so on. So what's important to notice about the values for x for both of these sequences, it doesn't start with x equals 1. It starts with x equals 0. So typically you think about the sequence and you say, this is the first number in the sequence. It starts with x equals 0 for that first value. Okay, to write an equation in function notation for this arithmetic sequence, on the right-hand side, you see some steps that are very, very important to understand. The general formula is f of x equals mx plus b. The first thing that we need to do with the sequence is find the common difference because this is m. So the common difference for this sequence, if I look at each term in order, I notice that it's increasing by 3. So that is my common difference. My common difference for this sequence is 3. It's going up 3 each time. Now, the second thing it says is to identify the first term in the sequence. This is b. So the first term in my sequence right now is 10. Then all I have to do is plug in my values for m and b into the general equation. So f of x equals, where the m is, I need to put my 3, x plus, where the b is, I put my 10. And that's all there is to it. That's all there is to it. Now when we take our MCAs at the end of the year, they will give you this f of x equals mx plus b for arithmetic sequences. What you have to be able to do, though, is you have to be able to remember what numbers you plug in and where they go, So that's the challenge to you, to remember that first you do your common difference, and that goes in front of the x, and then your first term. So anything that you can think of to remember that would be great. So common difference and then first term. Okay, here's the next one. So the common difference on this sequence, each time, if it goes from -4 to -2, it's going 2 to the right. So it's increasing 2. -2 over to 0, increasing 2 again. So f of x equals 2x because it was increasing by 2. And then I need my first term. It's -4, so I will just write -4. If you want to, you could write plus -4. It means the same thing. So common difference goes in front of x. Common difference. And then first term is b. The next one, this one is going down 5 down 5, because the numbers are getting smaller. So f of x equals negative 5x, because it was going down 5. And then my first term is positive 5, so plus 5 for b. Now we're switching over to our geometric sequences. The geometric sequences have a general rule, f of x equals a times b to the x power. Again, this will be given to you on your MCAs, so you don't have to memorize it. You just have to remember how to use it. And what's so tricky about this is that it doesn't really go along with the letters in the arithmetic sequence that we just talked about. So for this rule, it says identify the first term. This is A. So my first term is what I start with. My first term is 2. Then B is the common ratio. That means what it is multiplied by. Common ratio uses multiplication. Multiplication. So the common ratio is B. So what's happening on this is it's multiplied by 3 each time. So B is 3. So the order that you find those two pieces of information in for a geometric sequence are the opposite of what we did with arithmetic. So for arithmetic, we had an M and then a B, and it was the common difference first, then the first term. Now we have an A and a B, and it's the first term, then the common ratio. So the two pieces of information have flipped around. They flipped around. So if I plug these in my equation, I get f of x equals A is 2 times 3 to the x power. You may see it written with a dot to multiply or written with parentheses around the b value, which in this case was 3. So either of these would be acceptable equations. The next one, remember we have to start with our first term. A is our first term, so 1. And then this one is multiplied by -4 each time because it is flipping back and forth between positive and negative numbers. So times -4 to the x power. So first term comes first in this one, and then common ratio. This next one, the first term is 100. So I start with 100. And this common ratio, it's being divided by 2 each time. So what you have to remember is that dividing by 2 is the same as multiplying by 1/2 because multiplying by the reciprocal. 2 over 1, the reciprocal of that would be 1 over 2. So dividing by 1/2 is dividing by 2 is multiplying by 1/2, taking half of a number. So if it's a division relationship, you have to be able to convert it into a multiplication relationship because they're inverses. So again, dividing by 2 is the same as multiplying by the reciprocal. So the reciprocal of 2 is 1/2. And that's called our common ratio. One more. This one is divided by a -2, divided by a -2 each time. And it's starting at -36. So first term, -36. And that ratio, if you're dividing by -2 or dividing by -2 over 1, I would multiply by the reciprocal. So flip it over, and you still have a negative. It's -1/2, multiplied by -1/2. Okay, now you're ready to write your summary, and then you have a worksheet to work on. Please remember that if you're struggling with keeping track of the steps, you could always use substitution to figure out which rule goes with which sequence. So I want to explain that to you for a second here. So I'm going to go back to one of my arithmetic sequences right here. And I'm going to remind you that on the vocab page we said when x equals 0, 1, 2, 3, and so on. And I want to show you what you could do with that information. If I plug in a 0 for my x, I should get the first term in the sequence. Negative 5 times 0 is 0, plus 5 is 5. So I did get the first term in the sequence. If I plug in 1, I should get the next term in the sequence. So I'm going to plug in 1 now. Negative 5 times 1 is negative 5, plus 5 is 0. Perfect. So I've got my first term, I've got my second term. So that's how you can check to make sure that you've got the correct rule to go with your sequence. You can plug in the values, 0, 1, 2, 3, and so on, and check to make sure that it works. The same thing is true for geometric sequences. So let's say I use this one. If I plug in 0, because remember the rule, again it said when x equals 0, 1, 2, and so on. So if I plug in 0, here's what happens. And you may want to use a calculator for this because of the exponent. Following the order of operations, I have to do that exponent first. 1/2 to the power of 0. So that means like the number 1/2 or even 0.5 to the power of 0. If you put that in your calculator, you will find out that it equals 1. So 1/2. So 1/2 to the power of 0 is 1. Now 100 times 1 is 100. So my first term is 100. Perfect. I could check the next one. So all I need to do is plug in 1 this time. So f to the first power, 100 times 1/2 to the first power. 1/2 to the power of 1 is just 1/2. 100 times 1/2, half of 100 is 50. So my next term checks. So that's how you can check and see if you have put the first term and the common ratio in the correct order in your equation. That's how you can check. So for arithmetic and geometric, please remember that the purpose of this part of our definition is to check and make sure that you filled them in the correct order.